understanding big data and why it is relevant in today's world, followed by a 10-minute break, and then we will move on to Hadoop architecture. For those who are making notes, please sit back and relax. So we will be sharing this recording with everyone present here. No Big Data stands out for having instructors who encourage questioning. So please keep those questions coming. Since this is an introductory session, we have a lot of attendees, which is why everyone is muted. So our instructor will read out a question before answering it. The chat window is your primary mode of communication with the instructor today. You can ask your questions by typing it in. So to get better answers from the instructor, please keep your messages short and avoid chat language. This is session 1 of our 11-part course for Big Data and Hadoop, but on its own, it will suffice as an introduction to big data technologies. So before introducing you to Big Data and Hadoop, let me introduce you to Know Big Data. Our primary focus is online trainings relating to big data and data sciences. We have instructors who are industry experts. You will soon find out during this session how true that is. As part of the course, we provide access to Cloud Labs, which is a cluster that you can use to play around with whatever you learn during the classes. This feature is unique to Know Big Data and gives you a real feel of how things work at organizations that use big data technologies. Course takers are also given lifetime access to our learning management system, which will include all the presentations, video recordings, assignments, and project work. At the end of this course, you will get a real-life project to complete, and you will be receiving a social media compatible certificate. So this will include 24/7 online support. Apart from all this, we also have our alumni group, which we refer to as Knows Big Data, which will keep you posted on new job opportunities and help you stay updated and connected. So let us move on to today's session. Our instructor today is Sandeep Giri. I will let him introduce himself and take it over from here. Have a great session.
Hello everyone, this is Sandeep Giri here. Are you able to hear me clearly? So we have around 36 attendees. So all right. So most of you are able to hear me clearly. Okay, we have Saif, we have Pankaj, we have Suman, we have Vivekananda and Sagar. Great. So this is going to be a great session. And even if you are not well aware about programming, at least attend the first session definitely. This will give you a clear perception of what is big data and whether the whole technology stack suits you. All right. Now, all right, so a little bit about myself, but before I tell you introduce you about myself, can you also introduce yourself with a single one-liner? Okay, it will be great. Okay, so please introduce yourself with a single liner, one-liner, and so that I know that who is my audience. Great, great. All right. Yes. All right, a little bit about myself. I from down to up. In 2002, I finished my BTech from IIT Roorkee. Afterwards, I was working at a company called DE Shaw. So at DE Shaw, we were working on big data systems even before the term was coined. So we were having hundreds of terabytes of data back then, in 2002, 2003. So we were having a 10,000 node cluster in those times, and we were actually handling large amount of humongous data before the Google reached to that level, even before Amazon. All right. And afterwards, in 2006, mid 2006, I started a company called Tbits Global. We basically build a document management system for large organizations. And that was similar to what we have MongoDB. And afterwards, I joined InMobi and then Amazon. At both Amazon and InMobi, I worked on handling a very humongous data, okay, into machine learning and data sciences part. And in 2014, last year, mid last year, around July, we started working on no big data. Our extreme focus is on our user satisfaction. And basically, there is a gap in the industry between expert instructors into the advanced technologies. Therefore, we started no big data. There's a huge demand and there is a huge gap. Okay, although everybody seems to claiming about big data technologies, but there is still a huge gap. All right, so that is about myself. I'll So today we are going to talk about big data in general, and then we will go into the architecture of Hadoop, and we will also discuss HDFS today. All right, this session is getting recorded, so no worries. Again, welcome to the session, and you are definitely going to have a great time today. Alright. So we have Nandita. Nandita used to be a database programmer. Welcome, Nandita. We have Vivek Subramaniam. Okay, Vivek, a little bit more about you will be better. We have Pankaj, who is working with Barclay Technologies as project manager. We have Ragini, and Ragini is a web content developer looking out to make career in big data. Welcome, Ragini. This session will give you a clear picture. And we have Sai Krishna, who is who is currently interning at Cisco. Great. Welcome, Sai, to the session. And we have Deepesh Garg. Deepesh is an architect. Welcome, Deepesh. It'll be great if we, get to know about you more. We have Sagar. Sagar is an Android developer and is a MSc Computer Science. Great, great. Welcome, Sagar. And definitely you will find this session informative enough into big data. We have Suman, and Suman is an MBA in IT concentration. Great, great. We have Presil. Presil is working as software developer at Ameda Software Labs. Great. We have Seth, who is a supply chain logistics. So we have actually a great set of uh, audience here, and Seth is all into information systems development. All right. Welcome, Seth, and welcome all. We have Kiran, who is Linux technical solutions. We have Lakshmi here, who is 5 years experience in Cisco networking. Great, Lakshmikant. And Vivekanand is Director of Product Development. Great. Welcome, Vivekanand. I look forward to have more interaction, more questions with all of you. And Rajesh is from Informatica, working in the data quality technologies. Welcome, Rajesh. You are definitely going to like the session, and I'll try my best to you know explain the things clearly. We have Lalit, who is working as SAP consultant, as SAP India as consultant. Great, great. We have Richa, who is working at Dell International. Welcome, Richa. And we have Kiran from HP Techland. Great, great. Who is working at HP as a senior tech lead. Okay. Welcome, Kiran. And again, so let's start. All right. So today we are going to discuss why, and what is big data. Then we'll talk about why now. Who are the customers, example customers of big data, and is big data for you, that kind of questions will be answered during this session. All right. And we have then, all right. Then we will proceed after the break into what is Hadoop, components of Hadoop, HDFS architecture, and if time permits, we'll get into the architecture of MapReduce. And then those who have already signed up for the course, we will uh, d- discuss in detail about the assignments of the course. Okay, so all right. All right, so before we start, let me understand from your point of view, what do you understand by big data? Okay, let me try to gaze what is your understanding about big data. Okay, Sagar says large volume of data, and Vivekananda says unstructured social media data. Okay, Ragini says large set of data, large amount of data is safe. All right. Nandita says correlating not so obviously connected data. All right. All right. Rajesh says loads of data which cannot be handled by traditional databases. Good. Good. So a great set of answers. Great set of answers. Immense amount of data, thousands of gigabytes, large amount of data from Richa, multiple Excel sheets, multiple databases, unstructured database, large amounts of unstructured data. All right. Presil says when we have huge amount of data which cannot imagine managing through normal database technologies, then we have great, very great set of answers. Okay, we have all right. So yeah, so in very simple words, the data of very big size is called big data. Now, how big should it be? Okay, now it should be it should be so big that you cannot handle with your usual tools. Okay, and what do we mean by usual tools? The tools which run on a single computer, such as your normal file system, such as your traditional databases, and and therefore, to handle such a data, you require distributed architecture, meaning multiple computers. All right. The data could be in any form, it could be structured or unstructured. So we'll talk about what is distributed architecture and what is structured and unstructured data. All right. Good. Good. Great. So we have got a great set of answers. Thank you, Pankaj and Manoranjan. All right. So we talked about three things. First, big data is such a big data that you cannot handle using traditional databases or traditional file systems. And to handle that kind of data, we require distributed architecture. Okay. And when I say handle, it means handle in reasonable amount of time. Okay. There are tools which can handle the data, but they will take 20 years to finish the work. Then we cannot say that they are able to handle the data. All right. All right. Now, so I hope this definition is clear to everyone. Before we go forward, let's talk about what are the kinds of computing. First one is the two predominant kind of computing you will keep on seeing all the time. One is distributed computing and other is parallel computing. So the difference between distributed computing and parallel computing is, in case of distributed computing, the nodes are connected. There are multiple processors and multiple memories. While in case of parallel computing, there is a single memory and multiple processors. Okay. Or in very simple words, if you take your normal computers, connect them in a network, we call that, and then make them do something which make them do a single task parallelly. Okay. If you connect multiple computers into a network and then make them accomplish a single task, okay, in a very very fast manner, then we call it that we are utilizing distributed computing. But if you have built a single computer with multiple processors and a great set of RAM, and you're making use of all these processors parallelly in your program, then we call that as parallel computing. All right. So that's a type of computing, and we will be focusing on this distributed computing. The difference with this distributed and parallel is that for parallel you have to build a special set of hardware. For distributed, you can utilize existing set of hardware. All right. There are the other thing is that we also talked about that big data is something which can handle both kind of data, structured or unstructured. So this is a common definition which we all have agreed upon. So when we say data, what does it mean? Data means some information. Okay, some information. That information can be we for that information whatever presented to you, you will have a clear segregation of records, and within a record if you have a clear segregation of field, we call it as semi structured data. If within the fields we also know clearly that what is their data type, then we call it structured data. So in structured data we know exactly what are the fields in the input. Okay. We also know that what are their fields data type. For example, when somebody gives you an Excel sheet, you know clearly that this Excel sheet has got 20 rows, and in each row there are these 15 columns, and each column, some of them is integer, some of them are dates, some of them are text, and some of those is drop down. Okay, so that is structured data. Similarly, when somebody gives you a database table and tells you that here is your data, you can just start using MySQL. Then also you know that clearly that this is structured data because you know the fields, you know their data types. Similarly, if you are given the data, you know how the fields are separated, but you don't know what are the data types of fields, then we call it semi-structured data. For example, comma separated file. In comma separated files, we know that the data is comma separated, but we do not know what is the data type of each field. Third is unstructured data. In case of unstructured data, we neither know the data type of the field nor we know the how the fields are divided. Okay, we do not know the structure of the fields, and we also do not know the data types. So that is called the structured and unstructured data. All right. Next, I will take the questions. I will take your questions after this slide. So yeah, but that does not mean that you do not ask the questions. All right. So again, this is the traditional definition of big data, which I would cover. And here I would like to tell you that this definition does not help us in deciding whether a given data is big data or not. All right. This definition only tells you that what are the reasons that might cause a data to become big data. Okay. So for example, in this definition, it says that data can become big data by virtue of four properties, or either of the four properties, or one or more of these four properties. One is volume. Although these things are very obvious, data has got volume, data has got velocity, data can have variety, and data can have veracity. Okay, so volume means you have got terabyte of data. So, so I will again and again enforce that idea of distributed computing. So when by virtue of the volume of the data, we say that our data is big data, because by virtue of the volume of the data, we realize that we cannot handle this data using a single machine, meaning our file system is not able to store that volume of the data, then we call that data as big data. Or if the data that is coming from the users is at such a fast speed that our single machine is not able to handle it, then we call that by virtue of velocity, our data seems to be big data. And sometimes it's neither the volume nor the velocity, it might be the variety. Meaning, there are certain cases. So let me take one example of each. So volume could be that there are a lot of data stored in Facebook. Okay, a lot of people have uploaded videos, uploaded photos, this and that, and that volume is humongous. Okay, so all these stored pictures constitute the volume. While when the moment you log in into Facebook, you will be asking Facebook for your feed, right? The feed to display. So similarly, there are millions of users who every second are asking for the feed. That is called the velocity. There are so much velocity of the data, and this velocity and the data is the request you are sending. So that is velocity. Now third one is variety. Now this is something really interesting. So when we say variety of the data, it means that, say for example, we have got Google Maps. Okay, the Google Map size of one state might be hardly 10 GB. For one state in a country, for one state, the Google Map size is maybe like 10 GB, or maybe 15 GB, or maybe 20 GB. Okay. Now, although this data is not huge and the data is not changing, but because the kind of data we are handling is complex, or the kind of requirement we are having is complex, okay, therefore we call that by virtue of by virtue of the variety of the data, or by virtue of variety of our problem statement, our data we cannot handle this data using one computer, and hence we are having the big data issue. Okay, the fourth one is veracity. Veracity is something very vague term. Okay, this has been just introduced for the heck of it, but let me explain what do they mean when they introduce the term called veracity. They means IBM people. Now veracity means by virtue of confusion, because of the confusion that whether to keep a set of data or just drop it. Okay, because of those kind of reasons we end up accumulating volume of the data, and hence veracity leads to volume, and thereby leads to big data. Okay, so imagine that you are planning to do a temperature analysis of the whole global warming. For global warming, you are planning to do the temperature analysis of the whole globe. Now, now you have been given 10 sets of data with different parameters and with different characteristics. For example, one data set could be based on zip code, other data set could be based on GPS locations, and there could be another data set which is based on GPS coordinates. Along with that, it's every 5 minutes. So unless and until you figure out that which data is best and which data should be kept, you cannot discard one data set, or you cannot keep only one data set. And therefore, instead of handling one data set, you end up with 10 different kind of data sets. Okay. Also, in these 10 different data sets, maybe one data set is a derivative of other one. Somebody took another one data set, and or somebody took a GPS coordinate data set and prepared the zip code data set. Now, until you till the point you reach to a conclusion that this is the data set that need to be kept, and these are all the data sets that need to be discarded, this whole volume need to be handled, and therefore this confusion or the veracity would lead to the volume and hence big data. All right, so that was those were four examples of big data, okay, each defining the characteristics of big data. All right, so here are so many questions asked by you. So first is Seth. Seth is asking, does big data have any relation with RDBMS? So the answer is yes and no, because at the end of it, it is data. And traditionally, we have been handling data using RDBMS. All right. And therefore, the intention of whole of the big data industry is to bring the processing and be able to handle the data the way we had been doing. So everybody is busy in building the tools which look like RDBMS. For example, Hive, Shark, Pig, and all of these tools, they are trying to handle big data, but they're trying to give a presentation to the end user like that of RDBMS. So that is the correlation between the big data and RDBMS. Kiran's question is, can we say parallel computing is like high performance computing? Yes, that's correct, Kiran. Suman's question is data colon row information. Okay, probably you were saying about structured data. So Rambhushan, yes, you have been muted by organizers because there are more than more than 60 people in the session, 62 people, and if all of them are unmuted, it'll become impossible to manage. All right. So you can ask your question by typing. All right. Good. Thank you, Suman. You like the examples? Prasil say an example of unstructured data. So okay, so I forgot to give the example on unstructured data. Thank you, Prasil. So yeah, so unstructured data could be something like logs generated by your programs. Okay, or unstructured data could be the data in the form of videos, the data in the form of binaries. Okay, so that's an example of unstructured data. Okay, so Rambhushan is not able to connect, listen to anything, so I am just sending him. All right. Okay. Thank you, Pankaj. And yes, so that's veracity is little itself. It's a confusion thing. Okay. All right. So Jakaria's question is, can you please give some real life examples of structured, semi-structured, and unstructured data? So the biggest real life example I could provide you, for structured data, you have normal database tables. or you can also to some extent say your data sometimes in Excel sheets. Okay, and semi-structured could be something like XML, or semi-structured could be in the form of CSV file, comma separated file. And unstructured data could be the data accumulated from various uh, source which are unknown. For example, the logs gathered from various places. Okay, and other real life, I don't know how to express it in real life. So other thing you can think of, any OLTP relational database, or any data stored in ERP, SAP, all of that is structured data. Okay, while semi-structured could be the data you have been given by your the bank statement given by to you in the form of CSV file by bank. And unstructured data could be the data given to you by your medical practitioner as PDF file. Okay. Okay, so Deepesh's question is, if the data is terabyte which can be handled by RDBMS, then is that big data? So in case your RDBMS is able to handle and your problem is not that difficult, then if you are able to happily handle everything using relational database, then you don't need big data solutions. All right. Okay. So here this I'll not be able to repeat because it will be injustice to other people. Okay. So you have not missed much. No worries. So okay. Now Ravi's question is, why cannot big data be handled by RDBMS? You will see that example. What are the limitations? Okay. Now, Boomerang's question is that an approximate what data size can we go to big data environment? Okay. So probably your question is, what is that cutoff limit when we should start realizing that we require big data? So it's a function of two things. One is your data growth plan and your current data. Okay. When you draw two things, the moment you have data beyond say 10 terabytes to process at a time, then you should start thinking about moving to big data. All right. All right. So Projecta's question is, what is the basic difference in Hadoop, Big Data, and Excel sheet? You will understand this as we go ahead. All right, no worries. And so Boomerang's question is, can we go to big data ecosystem if my data size is more than 1 TB? So as I was telling you, it's not only the volume. Okay, what you are saying is, what if my data size is 1 TB? So 1 TB can sometimes be handled by normal file system and can be handled by your relational database, provided what kind of problem are you trying to solve. If you have 1 terabyte of Google Maps, or 1 terabyte of maps of any place, and you are trying to find location from one point to another, then definitely none of the existing solutions or which run on a single computer can solve your problem. You definitely have to move to a big data solution, which is a distributed computing, meaning you will have to set up your own cluster. All right. Now, Sai's question is, why is block data semi-structured? Okay. So block data is semi-structured because block data contains everything. It contains text, it contains images, it contains everything. So you don't know exactly what is the how to how to process the data. So that is Correct, Nandita. So, Nandita's question is, what about the photos we upload here and there, and we assign some categories? So yes, that you can say safely it's the semi-structured data, but photo itself is difficult to process data and is considered as semi-structured. Correct. So bank statement generated by bank system will be, if they are coming to you in PDF format, they will be considered as a semi-structured or unstructured data. All right. Suman's question is, so that means even if the data is comparatively large but can be handled with normal server in our small offices, then we don't need Hadoop. That's correct. So if you can handle your data that way and you do not have any plans to grow your data further and your data doesn't look like it will grow further at all, then you should be content with your relational database. That's correct, Ramesh. All right. Now moving on. Okay, so a quick question just to check if you are awake. And so, how many bytes are there in a petabyte? First answer, and then I'll move. Correct. Thank you, Boomerang. And all right. So, yes, it is 1024 terabytes. Correct. Or it has got 10 to the power 15, meaning 1 followed by 15 zero, those many bytes. Okay. And a better way to remember it using kilo mega giga terabita exa, each one is 1024 times the previous one. Okay. And 1 byte is 8 bit, which means you can imagine 8 byte, 1 byte as 8 switches. And using 8 switches, you can actually count up to 256 states. You can think about it. You can think about it. So basically, 1 byte can store up to 256 numbers. All right, great, great. So whenever we are counting the data, all right, now question to all of you is 1 petabyte a big data or not? It's a tough question to answer, but still, I'll not let you sit on the fence. Uh, if you are saying maybe, then you give your reasoning. Right? So we talked about what is 1 petabyte. 1 petabyte is 1024 terabyte, and 1 terabyte is 1024 gigabyte. Now, our traditional, as of now, the hard disks we have is usually from 2 terabyte to 8 terabytes that are coming in the market right now. Okay, so my question to all of you is that is 1 petabyte big data. And what is a big data? That cannot be handled using traditional systems. And for that, you require distributed computing. So Rahul says no. So give your reasoning, Rahul. Aman says no, it's not the data size which classifies as big data. Very good point. Now let me ask, okay, let me add on to my question. When I say 1 petabyte of big data, the question is, what am I going to do with 1 petabyte? Is it going to be just lying there and I'm not going to even look at it for next 10 years? Or what is it that I want to do? If I'm not going to look at it, 1 petabyte data, then it'll be, well, I can put it in tape drives and put it in the data center. and forget about it. But let's say I have got 1 petabyte data, and all I want to do is every day I want to count number of lines in that data. Or all I want to do is every day I want to go through each line and count how many vowels are there in that whole data. All I want to do is count how many vowels are there in that data. Now can you tell me, is this big data? Aman, the question to you. Suman, to you too, and Rahul, Saf. Okay. Yes, correct, Nandita. So yes, I did tell that if your data goes beyond 10 TB, it might be a good reason to move. Okay, I want to see your point of view. Kiran says, can be in case IOs or requests reach petabyte, then it is big data. Okay. All right. All right. Okay. So I'm just going to look at the the answers which say, okay, so yes, in general, 1 petabyte is considered big data. Reason being, even if I'm doing a very small processing like counting vowels in the whole 1 petabyte data, it is going to take around 5,000 hours to actually go through line by line. Okay? Because it takes 5 seconds to read 1 gigabyte of data, and to read 1 petabyte of data, it will be 5 million seconds. Okay. Now you can imagine, and therefore it's not the processing, it's not the computing, it's the IO, disk IO, which are going to trouble us. And let me tell you, there are few more also. Okay. Also, it does not mean that you have to have 1 petabyte data. As I gave you the three examples, in case your problem statement is difficult, for example, you have to churn a really complex data, then even few gigabytes of data might become a big headache for a single machine. Okay. All right. Now, next question to you, all of you. Already I have answered this. If you have heard what I have said, then you can answer. How much time does it take to read 1 terabyte of data from hard disk? From hard disk, not solid state drive. Anyone? So IO speed, you can take a safe assumption, Sai. You are right that it depends on IO, but you can take a safe assumption in case of hard disk. Correct. So Lalit's answer is correct. 1024 into 5 seconds, which comes to around 3 to between somewhere between 3 to 4 hours. Okay. So it takes 5 seconds to load 1 terabyte from normal hard disk. Okay. And therefore it takes around maybe 3 to 6 hours. In the older hard disk, it takes around 6 hours, and to load 1 terabyte of data. Okay. So now you can understand that have you ever tried copying 1 terabyte of movies from one disk to another? If you have, then you will be able to correlate. Correct. All right, so that is so this is a traditional graph you can see here. The graph, if I have to summarize, it shows that the analog information is stored in analog devices such as paper and the su- uh, such as the paper, film, audio tape, that is not increasing, while digital information stored in hard drives, solid state drives, and I mean USB flashes, that is increasing exponentially. And that's what it says. And it all started in 2002. And the reason were two things. First was smartphones, other was the connectivity. So smartphones started becoming cheaper, faster, and smaller. Cheaper, faster, and smaller. So that means they became everywhere. We were able to use smartphone as of today. Nowadays, everyone has smartphones, and smartphones act like a data generating machine all the time. You are receiving calls, sending messages, and all the time your machine is sending logs to the server that I'm up. At the same time, your mobile is, or you might be using mobile to take pictures. Your GPS location is getting recorded. Your how many steps you have walked, that is getting recorded. So your phone acts like a big data generating machine, while the connectivity, on the other hand, that started with first 2G, then 3G, then now 4G LTE, and we have Wi-Fi, and we have Bluetooth. All of these, the communication channels, they act like data spreading machines, data spreading systems. So connectivity multiplies the data generated by smartphones, and therefore both of the things, there have been a revolution in the smartphone, and there have been a revolution in connecting technologies, and both of these together have contributed to generating the data exponentially. So, and on the software side, of course, to support hardware, you need to have the software, and new softwares, innovative softwares connecting people and connecting people with the machines and machine to machines. All of the three innovations are happening parallelly, making it more and more reason to accumulate data, to be to build the capability to handle the accumulated, or to handle the live data. That is the role of these softwares. All right. So Bhagwan's question is, what exactly does digital data means? So when you write something on the paper, or when you were recording something using magnetic tapes, those were considered as analog. But digital data means everything gets converted into bits, 0 and 1, and then gets recorded. Okay? So Suman's question is, iCloud is a big data. Yes, iCloud handles a lot of big data. If you look at from iCloud's perspective, iCloud, if I'm assuming you're talking about Apple's iCloud, right? And they must be having iCloud, Dropbox, Google Drive. They all are handling humongous data. All right, so now question to all of you is, which components out of this list impact the speed of computing? Anyone? Sai says, okay, let me not speak the answers of others. So which components impact the speed of computing out of these A to Z, A to G for God? CPU, memory read speed, disk read speed or write speed, disk size, network speed, or all of above. Awesome. So almost all of you have said G, and that's correct answer. So although as opposed to the common psyche which we carry around is that it's only the CPU that matters. I mean, that's what the whole processor industry has been pushing. Intel has been telling the world that it's only because of the Pentium 4 or Pentium 3 the computers became faster. Not really, not really. So if you think about it, if you compare today's iPhone and iPhone 4 years ago, which were iPhone 3, the processor in iPhone 3 was around 200 megahertz, and that was also able to handle lot of processing. Okay, so processor is hardly a bottleneck when we do the computing. There are other factors. These all other factors impact the computing. Let's have a look at it. How do they? So yes, Kiran's question is even file systems do play a role. I believe, am I correct? Yes, you are correct, definitely. And that's what I'm summing it up in D and E. File system means disk read speed and disk size. So Seth, no, disk read speed have an impact. Okay, I'll show you why. So all of these components impact the speed of computing. All right. So yes, all of above. Okay. So in general, these four parts, that's what I have mentioned here. 3 plus 3, which is 1, B and C, DE, and these are the four components. CPU, RAM's speed and size, then network and disk speed and size. So all of them build up the computing environment. Okay, so by default, when you have huge data, you store it in the disk, then you load it in the memory, then you start computing. Sometimes when your data starts growing big, you might have to have load some data from the network, or you might have a central database from where you might be reading the data, and is uh, that is impacted by your network speed. So overall, whatever computing you're doing, sometimes all four become your speed might depend on all four of these components. Okay, and as a developer, as a programmers, people keep on shifting the load from one component to another. For example, if network speed is taking too much time, people start transferring the data to local, which means disk will become the bottleneck. And when the disk read or disk speed is hurting you, you start loading the data into memory. You start buying more and more RAM or the memory. You start loading the data from disk into the memory. After that time, memory becomes the problem. And in case memory doesn't become a problem, your computing, the CPU will become a problem because there's too much of data to process in the memory. Okay, so basically, all of these four components are the bottleneck in the computing. All right. So yes, so when you have these kind of four things, any of these four, or at least one of these four, will become the bottleneck, and then you will say that my problem cannot be solved by using one computer. We need to figure out any other solution. Okay, say your CPU becomes a bottleneck, you start adding more CPUs, then RAM becomes a bottleneck, then you start adding more and more RAM. Then your disk becomes such a big block, meaning the disk IO, as I was telling you, even if you increase the disk size, the disk IO, which means reading the data from the disk, will become such a bottleneck that there is no other way than moving the data to the network. Now the moment you start moving to the network interface will become the bottleneck. Then you say that my traditional tools are not able to handle. And that's when comes the role of big data tools to handle big data in parallel environment such that there is no network transfer. Instead, all the computers are reading the data parallelly, parts of the data being processed on all the computers. And then instead of bringing the data to another computer. We are sending program to be executed on individual computers. So I'll show you how to do that during this course. And that's basically that is biggest paradigm shift in the whole computing industry. Okay. Traditionally, we have been quite comfortable in handling the data on single computer. We had these three-tier architecture. There was a database. There is a middle layer which reads the data from the database. Then we handle the data in the middle layer, present it to the user. And we were pretty happy people. But the moment the data size started growing or our number of users start growing, then all of that standard way of handling data became useless. And that's what we are going to discuss in this session, how to handle various kinds of circumstances in case of big data. All right. All right. These are example big data customers, web and e-commerce. In case of web and e-commerce, number one is the recommendation engine. What does it mean by recommendation engine? Something which can give you the suggestions, something which can give you the recommendations. I'll show you in the next slides. So this is one example of the recommendation engine. So Amazon had been a pioneer in selling through recommendations. Okay. At one hand, you try to show ads to the user, right? That you may buy this, you may buy this, you may buy that. If those ads are not relevant to the users get frustrated, right? It's very irritating to the user. Now, if you make these ads very relevant to the user such that they figure out that this was not an advertisement but a suggestion to me which was really something I always needed, then then users feel happy and the chances of buying is really high. Amazon figured out that if they send recommendations in the email to the users, there are very high chances that they will convert. And that is probably their biggest way to engage the users continuously. They send the recommendation, they show the recommendation on their website. And since I have worked there, so I know that what does it mean to show a very close and very appropriate recommendation to the end user. Okay, we could all fill this whole page with advertisements, completely irrelevant suggestions we could give in order to increase our sales. But at the end of day, if the user is not happy, the business will go down. The business will keep running as long as business is pushing money. Okay, as long as business is burning money into advertisements. But okay, so but if the users are happy, if the users are really engaged and finding your product really useful or your recommendations really useful, then you are saving a lot of money of advertisement, a lot of money in giving discounts. So therefore the recommendations solve a lot of problems. Correct, Suman? Like Amazon recommendation. So when people visit the website of Amazon, we keep a track of who bought what without compromising individuals' privacy. Okay. So basically the headless data, we call it headless data, meaning the data without the user's information, the data without the user's information, where the developers do not know who is the particular user. Based on that, we try to figure out what should be recommended to who. Okay. So if you can see, there are two kinds of recommendations shown here. One is customers bought this item, also bought this. Okay. Basically, we are telling the world that it's not our curated, it's not our hand-picked information. We have figured it out based on people's behavior. Okay, that is why it may not be very biased. While on the second picture you can see where this with these things, that is more or less the handcrafted one. Okay, so both are called recommendations, while one left one is very much based on data, while right one is handpicked. And right one cannot be scalable because it is first, it may be biased by because of the people. Second, you require people to create such kind of information. All right. The third kind of recommendation, you can see that since you have based on your behavior, it's giving the recommendation. You have rated hundreds of movies, and based on that, it is saying that congratulations, movies we think you will love. Okay, movies we think you will love based on how many movies I have rated as good or bad. Okay, so these are also known as recommendations. And luckily, as of today's time, generating recommendations is actually a child's play. Okay, all you need to do is you prepare this kind of data where you mention what is your movie ID, user ID, and rating. And then there is a tool called Mahat, to which you can feed this three column data, and it will automatically generate the recommendation saying this user will like these movies, this user will like these movies, just based on this three column data. And how does it do it? First, it figures out which users are similar to each other, then group them together, and then start giving recommendations to them. All right, are you with me? Great. Now moving on. Next example of big data use case is sentiment analysis. What does it mean by sentiment analysis? Understanding the sentiments of your users. Traditionally, people would go around asking people that how is this company doing, or how is this product? Did you like the movie? So people do a survey. Okay, people do a survey. So for example, if you want to figure out whether people are liking the movie or not on the first day of movie release, people send these people we send the people to the various theaters, and they will conduct the survey. They ask people that how was the movie, this and that. Okay, and then based on that we used to plot the graph. But the problem with that was there was too much of manual work involved, there were delays, and there was a huge chance of data getting biased because data getting manipulated. As well, it was very intensive and there were delays. But now, given the fact that there are public channels like Twitter and there are other channels like World Wide Web, and then so based on that, you can do a lot of sentiment analysis, whether people are liking this movie or not. That's a sentiment analysis, understanding the sentiment of the people, whether they like it or they don't like it. Understanding this is the very important part of any individual, any business, any social organization, or any leader or any celebrity. Okay, so they need to understand what is it that people like and what is it that people don't like, and therefore they need to do a lot of sentiment analysis. Okay, and most of the sentiment analysis is based on Twitter sentiment, meaning understanding whether people are talking positive about you or negative about you, whether how many likes are you getting on your Facebook page on a particular message, or how many likes are you getting on on your Twitter itself. Okay, or because of a particular tweet, how many people subscribed, how many new people subscribed to you. So you plot that graph of popularity, or you plot that graph of sentiment, positive as well as negative, and then you say that, okay, this is how your popularity is going. Okay, as you can see that there is two lines, one is red colored, one is blue colored. Blue is the positive, red is negative. And here, okay, here you can see that at a certain point there are there are positive and negative tweets are equal, and at a certain point, meaning the negative tweets have grown to overtake the positive one. This is called sentiment analysis. To do the sentiment analysis you require big data analysis. Reason being that the bigger the data, better the information you will get. Okay, it's very common thing that the bigger data you have, the better response you will better will be your analysis. Okay, so Rashmi's question is Mahat a tool? Yes, Mahat is a tool, is a part of the big data ecosystem, and Mahat runs on data stored in Hadoop. Okay, so Suman's question is perfect. This is how I found out about the great use of. Congratulations, great, Suman. I'm happy. Correct. So lots of companies actually utilize these tools and techniques to gather very useful information such as sentiment analysis, recommendations, to in order to give their improve their organizations. All right. Moving on, going back a bit here. Now, other use cases of big data is search quality, sentiment analysis. Okay. Search quality, as in when even if your product is small, you are handling smaller data, but the expectation of your end user is really high. For example, in case of the product which we build on document management system, we hardly had 200 GB data to handle. Okay, in each organization, we hardly had 200 GB data to handle. Okay, and most of this data was unstructured, meaning documents, and PDF and Excel sheets. Now, this data, to improve the search quality, we had to do a lot of work. Meaning, first, what does it mean by search quality? Let's talk about. So when the user comes to your software, when they click on search, and they expect that they have to type minimum. First, you should be caching there what they typed last time. Second, when they start typing, you need to give beautiful recommendations. Second, and third, if they typed something wrong, you need to give the suggestion, did you mean this? Fourth, when user types something, and you should give the results about the synonyms. Okay, such as when people are searching for blue space dart or blue without space dart, they both means blue dart. Okay, you have to be able to handle such scenarios in order to give your users the best experience. Okay, and in order to do that, you might have to use a lot of data churning to build a beautiful thesaurus which has blue dart, the synonyms of all blue dart, BLUE DART or BLUDART, and a blue space dart, and all of these things in one single place. So to have to be able to build this kind of data, you need to crawl a lot of data. You need to download maybe you need to download a lot of data from across the globe and build this kind of thesaurus. Okay, so that is about search. Also, in case of search quality, user expects that even if you have got images in your data in your database, the user should be able to get the results. Okay, and to do that, it requires enormous amount of work. If there is a lot of images, then you cannot handle it on a single machine, because extracting information from images, meaning converting the image into text is a very high involvement process, and therefore it's not possible to do it using single computer. So search quality is actually one of the very big challenges. Even if your data is small, as I was telling you, even if your data is 200 GB and you need to provide search, you will have to do a lot of work if you are really passionate about giving your users the best. Next is A/B testing. So A/B testing is very important. What does it mean by A/B testing? So A/B testing is not a new term. Okay. Since the advent of medicines, the A/B testing has been going on. So to check whether a medicine has some impact or not, we some users are given medicine, some users are given the fake medicine. We call them pacifier, and we see the impact of whether a medicine had some impact or not. While both the set of users do not know, both the set of users believe that they have been given the medicines. Okay. So this way we can test a new medicine and figure out the impacts of it or not. Sometimes even doctors are not told that whether a particular medicine is a medicine or a pacifier, just to understand the effect of it. In a similar manner, in the software industry, when you talk about organizations like Amazon, various users get the various variations of a particular component. For example, you need to figure out which page header works best, or which buy now button is great best. So let's say you have come up with three different buy now buttons, and you are working on Amazon, and you have got three different set of buttons. One is blue, other is green, other is red. Now, to figure this out, what you do is for one third user, for you will show these three different buttons to three different set of users, and then you will see that which button got clicked maximum. Okay, which button got clicked maximum, meaning users were able to quickly discover the buy now button. How much time did it take for a user to discover buy now button? Okay, you compare these numbers and figure out that this particular button is better than the other one. Okay, and that is what is known as A/B testing. We are testing A against B. We are having three different set of data sets, and we are comparing one against another. Okay, so all right, so that is A/B testing. In telecommunication, figuring out why customers are leaving you, why network performance can be improved, and to analyze the calling record data, as in what's going on with the users. So all of this is a huge data to handle, and not a single computer can handle it. None of the databases can handle this kind of requirement, because first, these are complex requirements. Second, the volume is higher or the velocity is higher. In case of A/B testing, a lot of requests will be coming to your server, and to be able to handle them, to be able to route them to various scenarios, takes a lot of time and effort. All right, let me and then analyzing network to predict failure. This is another big data problem. Reason being, to be able to predict failure, you need to gather all the use cases, all the data, and then figure out in what circumstances, what is the common thing amongst the failure. So those are the reasons why would you use big data in these cases. Now let me take your questions now. All right, Suman. Okay. Now Seth's question if is Hadoop provide some built-in data analysis as well, or some coding Okay, is required. So Seth's question is that, does Hadoop provide the built-in data analysis as well? You will understand this part in as we go ahead when we talk about Hadoop's ecosystem. So Hadoop is made up of multiple components, and for doing the data analysis, there are different set of components, and for storage, there are different set of components. Okay, but for handling those tools, you might have to use either the UI or you might have to use a little bit of SQL or similar to SQL language. So is there a limit on how much data about people sentiment the big companies like Google analyze? Okay, so it is limited by their infrastructure, as well as it is limited by time, in how much turnaround time they require the results. Okay, so those are the two limiting factors, Suman. Now Deepesh's question is, from where can we download these data? So there are a lot of open source data repositories. You can search for Amazon Open Data. Then you will see that Amazon itself is providing a lot of data for free. Similarly, there are thousands of data sources from which you can actually download. Just search for open open free data sources and you will get a lot of information. Okay. Okay, so Deepesh's further question is like blue space data, BLUDATA, or blue data are same. So this is basically we call a text corpus data. Text corpus data is crawl data, which you can download either from Amazon or from Google, any of the places. They give you the data, but you have to build this by yourself. Okay, and I'm not sure if some company is providing you already. Suman's question is, what is the use of A/B testing in big data? Meaning, when you have lot of users and you have to figure out whether a particular feature is better than the other one, you basically show one feature to one user and the other variant to other user, and then figure out which one is performing good. So that's the use case of A/B testing. And to do the A/B testing, you require tools which can handle such a humongous load and hence distributed computing. Okay, so that is why A/B testing is a good customer for big data. Maheshwar's question is, there are many tools in the big data arena. How do you select the what and which products would be better to the customer? So Mahesh's question is very valid. His question again, let me repeat, that there are so many components floating around, which one to choose and which one is right to use. Okay, so first, to answer this, you need to understand what is your problem, what is it that you are trying to solve. Second is, you need to understand the second part, which is what are the various components providing. Okay, when you know both of these answers, you should be able to answer this question. All right, so we will try the first problem, which is understanding the customer, will vary from one student to another student that we cannot solve. But what we will try our best to solve is give you an overview of various components available in the ecosystem and how to zero down on one rather than getting confused about others. Okay, so we will discuss the details of all other products that is in the last session. Okay, not today. All right, great. So the other big data customers could be government. Government uses big data for lots of use cases, such as fraud detection. Fraud detection could be anti-money laundering, and where we are trying to track down the fraudulent transactions, and cybersecurity welfare. So for all of this, the government need to basically handle lot of data. And Figuring out a pattern in case of any fraud is itself a complex process. Grouping the data and based on the common characteristic is a very, very difficult task and is by default a complex process. To do all these kind of processes, you need to have big data, not only because the data is big, but because of the complexity of the problem. Okay, healthcare and life sciences. Now, health information exchange, gene sequencing, healthcare improvement, drug safety, in all of these cases, in healthcare, every data is humongous data. Almost every data is humongous data, and it takes a lot of hard work to basically handle that amount of data. This is just one slide where we are trying to show who is a bigger big data customer, and here the easiest way to figure that out was based on the Hadoop ecosystem. Okay, so this is bigger the font means they have more number of Hadoop uh, nodes. All right. Now this is 11 common myths which I have compiled. Basically, here I'm trying to show you that this is the common questions people keep on saying whenever we talk about big data. Some say that, oh, big data means always the data below or above in the range of terabyte. As I told you, that even the data, if the data grows to 220 GB, sometimes you cannot handle it on a single node. Okay, based on various correct things like how much time it is taking to solve your problem. So it's not necessarily in the terabytes range. Okay, it is always about social media. It does not apply to me. Okay, not really. The general assumption we always had was, since we are not into B2C, meaning we are not directly catering to the customer, therefore our problem is we would not have bigger data. But that is no more. That is more no more. Every organization, whether they are B2B, B2B is business to business, or business to consumer, all of them have realized that they need to gather the data, and because that's the only way of truth. Okay, rather than relying on some advisors, people now rely more on the data. Okay, third is that it will replace enterprise data warehousing. Okay, no, it will not. EDW EDW is finely tuned to solve certain kind of problem which none of the big data can handle. And most of the data which is there in EDW is not really so huge that cannot be handled by relational databases. Okay, so so mostly the EDWs and big data will coexist together and will have to figure out as going ahead that part of the data would be moved to bigger data, while the data which require current processing will remain in EDW, because there are things which EDW provides and big data does not. One of them is consistency of the data. Almost every distributed computing system suffers either from consistency or availability. We will go into the details as why the consistency is a big problem when we talk about CAP theorem or Brewster's theorem. All right. So EDW will not be replaced, they will coexist. And big data is just a buzzword, no practical applications. And moreover, those people who are working on EDW will have to inevitably understand the big data architecture in order to make EDW and big data talk to each other. Big data solutions to talk to each other, not big data. Okay. It's just a buzzword, no practical application. So this statement is still floating around, but the truth is that those days are gone when big data was new concept or was future. It is now the present. All right. So it's not future, it's present. It's not a new concept. It has been there for years. Those people who had the data, they were exploiting the data, but now the these tools are available to everybody, so it's up to everybody to start utilizing it. Okay, it's only for data scientists or is a magic? No, it's no longer for data scientists. As I showed you that Mahat can be straight away off the shelf used. Therefore, you don't require data scientists to build the recommendation engine. A normal developer can build the recommendation engine using state of the art tools like Mahat or MLlib. Okay, so it's no longer a magic. We have enough hardware, don't need any more. Okay, now what does this sentence mean? So most of the people that try to think that every time a new technology comes in, it comes with a new hardware. The truth is, in case of big data, most of these tools are built with distributed computing in mind, which means whatever your existing hardware is there, you can connect together and make the big data solution run. And therefore, it's actually the other way. Instead of buying new hardware, it actually utilizes your all hardware, okay, which is even not in use because your relational database is needed a better hard disk. So all of that can be existing hardware can be used. Okay, now the 10th one is probably the most fatal out of it, which is we will build it when we need it. This is something which I keep on hearing for lots of people, and the truth is that all those people who are saying this, that we will build it when we need it, they are actually closing their eyes. Okay, they need it in the sense that there are many use cases that they could utilize big data. It's just that they're ignoring it. Reason being that since they don't have the disk space to store such a huge data, they are ignoring all the use case of storing the data and hence all the insights. So it will take some time for them to realize that they have missed the data, and by that time they have already missed a opportunity window for analyzing lot of data. Okay, big data is about Hadoop. Okay, no, there are many solutions. I will tell you what solutions are there. And for example, these are the other solutions in the big data world. We'll talk about these. And a quick view for you. I compiled the salary trends in case of big data market. You can see that in case of Hadoop, the salaries are probably the highest, which means there is a demand and supply gap in the big data recruitment. Okay, there's a lot of demand, but okay. So this is one, you can see the graph, and here you can see Hadoop still is the highest paying job. Therefore, it makes sense to get acquainted with Hadoop. The more so reason is all the components that we will cover in case of this course. Okay, all of these components basically depicts one aspect of big data. Okay, so all other components, say MongoDB is synonymous to HBase that we cover in this course. Zookeeper is similar to other systems which we will study in future. HBase is also similar to Cassandra, which you will study further. And compute engine, anyway, we will take care of all of these components. So we'll explain you each and everything in today's session, and then you can take the call. Okay, so let's take a break for 10 minutes. All right. So we will come back at what time? It's now 32. Let's come back at 43 p.m. All right, are you guys with me? Hi. So let's take a break of 10 minutes and we will come back at 8:43 p.m. IST. Hi, I'm back. So should we start? All right, great, great. So, okay. So yes, Harsha. Harsha is asking if the session is going on. Yeah, actually that was a break. That's why you were seeing constantly the same screen. All right. So screen looked like struck. All right. Great, great. So everybody is on the same page, or so we were talking about the salary trends. So this is a generally you can actually go to Indeed.com or Naukri.com and see the current trends. That will be a good way to measure. All right. And the other big data solutions are other than Apache Hadoop is Spark, Cassandra, MongoDB, and Google Compute Engine. In case of Apache Hadoop, is probably the most complete solution, while Spark only provides the computing, not the storage, while Cassandra only provides storage but do not provide a very good computing environment. And similar is the case of MongoDB. MongoDB provides you a great storage, but does not provide you a great computing environment, a distributed computing environment. While Google Compute Engine provides you all of this, but it is not on your premise, it is in the cloud of Google. Okay. And by the way, whenever we say cloud means computer at somebody else's place. It is as simple as that. Or bunch of computers at somebody else's place. All right, so this is the reason. All right, great, great. So so we have done a basic homework on. We started with what is big data, then we talked about various industry trends with respect to big data, and then we talked about why do we need big data, and then we talked about various use cases, and then we talked about various available tools, example, and with respect to the job or career, the trends. So here we are. So now let's discuss, as we talked about on the previous screen, that Hadoop is probably Hadoop is probably the most the complete solution for handling big data. So what exactly is Hadoop? So Hadoop is so a bit brief history. It was created by Dog Cutting and Mike Caffarella. It is based on Google's paper on file system and MapReduce and Bigtable. There were three papers on which Mike Caffarella and Dog Cutting implemented those. Since they were trying to build a search engine like Google, they realized that they cannot build a search engine of that scale without having a great file system. So they implemented Google file system. And then they realized that they require a computing environment just like Google. So they implemented Google's MapReduce paper, meaning they followed what was written in the paper and then built this tool. And then they implemented Bigtable, which became HBase, that was their database. So file system, computing environment, meaning giving a program, run it on multiple computers, that is computing environment, and a database. Okay, all these three things, these two people or the team built it while they were working on Nut search engine in their personal time, and it is named after a toy elephant. Okay, the name which Dog Cutting son gave to the toy elephant is that name, and it's quite a simple name actually. Now the most important part is it's open source and the license is Apache. Okay, what does it mean to you? Okay, it means to you that you can use it in commercial applications. You can ship it with commercial applications. You can sell your applications which is bundled with Apache, but you cannot sell the Apache Hadoop independently without any modification or without any additions. Okay, so that is what it means to you. Apache license gives an enormous freedom, and probably this is one big reason why the Apache Hadoop is so popular. Had it not been under the umbrella of Hadoop, had it been commercial, it would not have expanded to this scale. There are definitely various commercial applications which might work similar way, but they are not as popular as Hadoop is today. And the single, if I have to give a credit will be to the open source license. The moment a company sees that okay, some product is open source Apache license, they feel very comfortable. They feel that they will not be tied down tomorrow. Okay, so that is the reason. And Hadoop is a framework to handle big data. Okay, what does it mean by big data? Meaning Hadoop is an umbrella. Now, after these three components, every now and then Hadoop product kept on adopting many other components under the umbrella. So Hadoop has become sort of an umbrella now. Okay, and it under the umbrella it houses various other components which are supposed to handle big data, and they are supposed to do what does it mean by in their definition of handling big data, meaning a computing which is very reliable, very scalable and distributed, meaning a computing in which if the program fails on one computer it should still run on another, and in case we have more computers, our program should not be modified. Similarly, our program should run parallelly in on multitude of computers. So if a component which wa- all the components under the umbrella of Hadoop have these characteristics. All right. And almost all the components under Hadoop are written in Java. The single reason why it's written in Java is so that these components can run on all kinds of machines. Okay. So is everybody okay with this? Yes, this webinar is being recorded, Harsha. Great. Now, any questions here? Should we? All right. So now these are the various components that are under uh, umbrella of Hadoop. Now we have a question from Pankaj, and probably that is the question which everybody else would be having in mind. Is it necessary to know Java programming to work on Hadoop? Okay. The answer is, what exactly are you trying to accomplish? Okay. If your task, so as I told you that these are, as you can see this here, there are many components that lie under the umbrella of Hadoop. Okay. So if you are trying to do simple, say for example, you are trying to store data in HDFS or take data from HDFS, you don't require the knowledge of Java. Similarly, if you are trying to use Flume, meaning importing data, so as we go further, there are multiple components. Only in the very highly specialized problem where you have to do things in a very specialized manner, only in those cases you generally require Java programming. Otherwise, you can happily live without knowing Java programming. Okay. So only in the cases where you have a heavy customization requirement, only in those cases you would need to know Java programming. Otherwise, you don't need to. It's as simple an answer. Okay. Does it make sense, Pankaj, to you? I know this question has been in your mind, everybody's mind. Now, next question from Pankaj is, do we need to have good knowledge on data structure? Not really, not really. It's not too algorithm intensive. Those data structure algorithms are more important when you're going for a data sciences class. But in case of Hadoop general development and Hadoop analytics course, you don't really require too much of data structures knowledge. Okay. And in this course, whatever or whenever I need you to understand a particular data structure, I will explain you the essence of it. Okay. But the basics of computing you should be knowing. Okay. Also, what I need to understand, I want you guys to understand is you should be okay with when you look at a for loop, you should understand that, okay, this is a programming construct and for loops are generally for this. Okay. Similarly, when you see a variable assignment, you can say that, okay, variable assignments are for this. So the basic constructs of programming, such as what do we mean by variables? What do we mean by a loop? What do we mean by a function or a module? So those concepts should be clear for this particular course. Okay. Because we are dealing with the technology components and those kind of things are common with probably every component. So Kiran's question is, so we can have Hadoop system admin consultant too. Yes, that is correct, Kiran. So we can have Hadoop system admin and consultant too. Okay. So Deepesh's question is, can we use Hadoop without NoSQL? Yes, we will understand this very quickly now. I'll explain to you. What does it mean by that? Okay. What are the technologies we need to know in order to become proficient in Big Data Hadoop? Okay. So other than what we are going to take care of in this particular session, the basics of computing you should be aware of. Relational databases, you should know how 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 exactly a SQL query looks like. Also, looking at a SQL query or you were looking at a problem, you can say that, okay, this is how I will write my SQL query. Okay, so the basics of databases are required for this course because we go into the details of all these components and how to utilize all these components to solve your problem. Okay, so Jakaria, I think I have answered your question. Have I not? So, his question is that, do we need to have good knowledge of Java? Not really, not really that way. Just need to have basics of programming clear. All right. So Ajay's question is, so as a Hadoop developer, what the major skills set look out for? Okay. As a Hadoop developers, you should be able to convert a problem into MapReduce if you are talking about becoming a Hadoop developer. Second, when people ask you that how to given a particular big data problem, how will you create the data model in HBase, or what will be the data flow? So all of those kind of questions you should be able to answer, but that's more of an architecture question. But as a Hadoop developer, you should be able to interact with HDFS programmatically, you should be able to interact with MapReduce, and you should be able to interact with HBase. Okay. And of course, there is one more component which is called Zookeeper. Will take care of Zookeeper also. All right. The basic knowledge is, first you need to know a little bit of a relational databases. You need to know relational databases. you need to know a little bit of programming, and you need to know a little bit of Unix. Okay, even if you don't know a little bit of Unix, we can basically help you out with that. Okay, you will learn during this session. Okay, you should be comfortable with command line. Okay, if not, then during the session you will become comfortable. Is MDM, I'm sorry, Sandeep, I missed your question. Is MDM and big data are integrated part or fully different? So both of them are a different component, but they are integrated probably, and because MDM can read the data back and forth from the Hadoop solutions. Okay. So whenever we say big data is a very general term, there are big data solutions. So when we are talking about master data management and big data, we should be talking about MDM and some database. Okay. So it all depends on drivers provided by both the sides. And most of the big data solutions, they provide the JDBC solution, and hence they can integrate with MDM. All right. Does companies consider non-Java skill person for big data openings? Yes, they do consider. If they are considering for somebody into big data analytics position, such as Hive or others, they do consider. Also, I have met lot of developers who were not from Java background, but they knew some other programming language and they did a good job. They were good at Python and they were good at some other language, but they were not good at Java at all. Okay, so even for the Hadoop developer position, people are considered for their knowledge on Hadoop along with some programming language. So when you're going for Hadoop development course, you should know some programming language. Lohit's question is both Hadoop and Spark interdependent? So Spark is independent tool. The thing is Spark runs on Hadoop as well, and therefore you cannot really say that Spark is and Hadoop are dependent, right? But they work in conjunction together. All right. Ankush's question is, how can I relate it with Salesforce? Okay, so there are drivers from exposed by Salesforce. Then you can connect. You can basically read the data from Salesforce and push it to HDFS. Okay, so it all depends on what is it that you're trying to achieve. Next question from Ankush is it good to know about big data for Salesforce developer? So Salesforce development is a small one development area. From time to time, you might have the requirement of moving the data from Salesforce onto other platform if your data is growing bigger. Okay, or you have some data being churned at the big data level, and you want to push that data into into your Salesforce. Okay, in those cases you might use API, but for those kind of requirements you don't really have to go deep into Hadoop development. But in case you are planning a little bit of a career switch, then you might want to do this. Okay, so Lakshmikant's question is, are there any certifications involved? Can we achieve the same by self-study or self-paced learning without enrolling for the course? That is, so it all depends up to you. So the course is actually heavily involved, this particular course. And although the information about the course is available on the website, but it is too much of dispersed. Okay, and the way it happens is here we have gathered all the knowledge at a single place, so you don't have to hunt around. Also, it brings a lot of discipline in learning, and therefore this kind of course is fairly useful. Okay, although if you are little dedicated, you can do the same thing by self learning. But in my past, what I found is only 3% of the people have actually completed the self-learning courses. Okay, only 3% of the people. So therefore, if you are really serious about these courses, and then I would strongly recommend it to you. Okay. Now, regarding the certifications, there are multiple companies providing certifications: Hortonworks, Cloudera, and there is other companies also who are providing certifications. In the similar manner, we also provide our certificate on once you complete our course and finish all the assignments. Okay. And it's not only the certification, we basically have industry connect. So we basically float your resumes once you finish our certificate. Okay. And we don't charge extra for certificate, it's just the usual one. All right. Now, Boomerang's question is, they say now the Spark is the future. Now MapReduce is replaced by Spark and Storm processing. Is that true? Okay, so let me answer your question, Boomerang. So basically, we cover Spark in this course. One class is dedicated to Spark, 2 hours class is dedicated to Spark, and that is actually sufficient to learn Spark. But Spark is an individual technology. It's not going to replace Hadoop. It is just going to be completed to MapReduce. Also, Spark and MapReduce are not really head-on. Okay, are not really head-on. If you want to do batch processing, you will still consider MapReduce, while if you want to do in-memory computing, you will do Spark. Okay, we'll talk about those parts. So Ashish Sinha's question is, can we leverage ETL, Informatica experience, while learning big data? Will Informatica experience help in any way? Yes. So see, if you think about the tools like Scoop and Hive and Pig, half of the job they perform is ETL. All right. And therefore, the ETL knowledge will definitely be helpful. All right. Ravi's question is, Flume is interacting with, okay. All right. So will that be okay if I, can explain the components? No, I think I should finish the questions and then we'll take up. There are around 8 more questions and we will finish this. Okay. Flume is interact with only unstructured data also. So we'll explain to you, Ravi, this while explaining the components. Hadoop can work along with OpenStack, Amazon, AWS. That is correct. It can work with S3. Okay. It can work with Amazon S3 and it can work with other tools. That was Kiran. So Sunit question is, I am an SQL developer with the knowledge of C Sharp. I'm currently learning MongoDB and Python. How do go about learning big data? Can you address the gap? Okay. So yeah. So if you have a knowledge of C Sharp, it's good because C Sharp is very similar to Java. And also, anyway, if you are comfortable with these programming languages, then it should not be much of a problem anyway, because Java is not really the hard requirement. And if you are learning MongoDB and Python currently, then it should be good enough. Okay. Also, MongoDB is just very small part of the whole big data ecosystem. It stores the data and it allows you to do a rudimentary computing. But when it comes to the big data solutions, you have a lot of layers of things. But MongoDB will help you understand couple of great ideas. Okay, and those will be useful while learning Hadoop also. For example, Zookeeper's architecture and MongoDB's architecture is same. We'll discuss Zookeeper in case of Hadoop also. Okay. Okay. So Lakshmikant's question is, for a CA working in finance sector, wants to know, a CA wants to know what insights does Big Data Hadoop contribute to his career? All right, that's a tough question. So, in case of, when you are talking about finance and when you are talking about forecasting, you need to know at least the list of strategies which you can utilize in order to do predictions, in order to do financial analysis, in order to do basically, say, for example, reconciliation. Okay. So big data kind of tools are being used in all of these circumstances. Okay. And there are new set of technologies which are coming up into all of these domains. So basically, as a CA, you need to know that you need to know the various techniques and strategies available as of today, and how they can help you. Okay, so it can be maybe with respect to reconciliation, with respect to the anti-money launderings. It could be with respect to the way you can do forecasting of your inventory. It could be based on forecasting of the financial data, or it could be as simple as understanding the status of the organization's stock prices based on the popularity over a period of time. Okay. So Sai's question is, how is it useful it is to do certification? So in my frank opinion, certifications do not matter. Okay. Reason being, those companies who are good enough, who have a good team, will already have a good set of people who can interview you. So they will not look at certification. Okay. The people who are looking for certifications are those people who have nobody to judge you, nobody to take your interview, and hence they will generally rely on a Hadoop certification. Okay. And generally, those people who are really looking for a big data developers, if they try to portray that they are looking only for people who have certificates, there is a very small inventory and they will not be able to fill the positions. Okay. Therefore, mostly the certifications are not really mandatory in the game. All right. So next question from Kiran is, can Hadoop work on software defined storage like Google FS and OpenNAS? Very good question, Kiran. And I think just remind me once I describe all of this. And we had a big discussion when I was giving a talk to IBM's leadership on exactly the same on the same topic. So give me time when I describe all of this. Okay. All right. Boomerang's question is, in your opinion, which will overtake Apache Flink or Apache Spark? That's a very big opinion, Boomerang, you're asking me for, and I'll not comment on this right now. All right. It all depends on how they are able to proceed. Okay. So now Rajesh's question is, successfully completing certification at no big data does enable candidate to easily clear? Yes, that I can assure you. If you are able to finish all the assignments and quiz questions provided by us, then because then your chances of clearing any other certification becomes very, very easy, very high. The, and the reason is the way we have stitched the whole course, it basically overlaps it's a union of what Hortonworks asks for certification and what Clouded asks for certification. Yes, yes, I. So you can basically, if you want, you can go for certification exam after this course. Ragini's question is, as a non-technical person, which one is better to start with, SAS, R, Big Data, and Hadoop? So my answer to you is you should have a good understanding of the whole the structure of big data and Hadoop, at least the understanding that what is it that Hadoop does, and what is it that what is it that we need Hadoop for. And when you compare SAS and R, I would prefer R over SAS. Reason being, SAS is SAS is not really open source and has got limited set of customers. If you compare R and SAS, then R's popularity is growing day by day, and R is far more popular than SAS. All right. In other way, if you know R, you can handle SAS easily, but if you know SAS, you cannot handle R so easily. So Deepesh's question is, can we use big data concept in transactional data? So yes and no. Some of the tools are okay for transactional data, but they are not capable enough. Even today, they are not capable enough to handle transactions so seamlessly as your traditional RDBMS do. So whenever it comes a question of transactional data, you generally avoid putting it onto the Hadoop or any other big data solution. Reason being, these tools are distributed, and every distributed computing suffers from transactions. Almost all distributed computing is uh, designed for scalability, able to handle volume and velocity, and the complexity as well, but not for transactions. Because if you start to provide transactions, the distributed computing actually falter badly. Okay, only single computer can provide you transaction. Multiple computers parallelly cannot provide you a great transactions. Okay, so that is one thing, though they try to provide, but not to a very great strength. So you will have to understand what exactly are you trying to do and which tools are you using, and if that tool provides you what kind of transaction support that tool is providing. So Ajay's question is, will certification help in case of a career shift, or just training courses are sufficient? So for career shift, if you are into non-programming kind of environment, a certification might help. Okay. All right. And it all depends on various organizations. Some ask for certifications, some do not ask for certifications. And in my personal opinion, those companies which are not asking for certification, I would prefer those companies because it shows that the company is mature enough to take their interviews by themselves rather than relying on third party certifications. All right, Nimesh's question is, how useful big data can be in analyzing stock market and predicting the levels of a particular stock. So people are using using big data solutions to analyze stock market, specifically tools like the other tools. For example, even this Spark people use for analyzing stock market. Along with that, people use Redis. It's a NoSQL database for doing that, and even to a very high extent, people use HBase, which is a part of Hadoop. All right. Now, Ragini's question is, in your opinion, how is the boom for R now? Boom for R now is good. I was analyzing the popularity of R against SAS. If you do not know, there is something called Google Trends. You can go there and compare the two components and see how are they performing against each other. Okay. You can use Google Trends and then compare the two. All right. As well, you can have a look at the Indeed.com's or Naukri.com's data and figure out the overall results. All right, so that was great set of questions. Now we have got around 45 minutes. So in next 45 minutes, we are going to discuss the components provided by Hadoop ecosystem. All right. Great. Now let's talk about the basic of the Hadoop ecosystem. The main component in the Hadoop ecosystem is Hadoop file system. Just like when we install a computer, the first thing we get is a file system. Whether we want to install the database or not is up to us. Okay, so in the similar manner, the file system is the basic component in case of Hadoop. All right, so we will discuss that now. All right. Okay, so we'll discuss it maybe after this discussion of each individual components, and then can go ahead and all right. Now, so there is a Hadoop distributed file system. What does it mean by Hadoop distributed file system? It means that a file system that runs on multiple computers. So Hadoop distributed file system is a component on which the whole ecosystem depends upon. Okay. The other component on which the whole ecosystem depends upon is Zookeeper. So on Zookeeper is basically another software construct which basically provides a way to for coordination between multiple machines. Okay. So that's not listed here, but we cover Zookeeper in one of the sessions. Okay. So Hadoop distributed file system is the base of the whole ecosystem. All other components depend upon the Hadoop distributed file system, and this file system runs on multiple machines parallelly. And we will go into the details later about the various components. Now, above Hadoop distributed file system, we have here, you can see. So on Hadoop distributed file system, the first thing that depends upon is Yarn. Yarn is a computing environment which makes it possible to run a program parallelly on multiple computers. So you have say 10 computers. All of those 10 computers are running HDFS and providing you a single file system. When you are interacting with Hadoop distributed file system, you will think that it's a single file system, while underneath some data is on one machine, some data is another, some data is on. So the data is divided into parts on multiple machine. We'll see it in the architecture of HDFS. So Hadoop distributed file system is the thing on which Yarn depends. Now Yarn is basically makes it possible to run the program on all the computers simultaneously. Okay, depending upon our own requirements. Okay, if you want to run the program near to a file, we can do that using Yarn. Okay, now on top of Yarn is just a general framework. It's like you can think about Yarn as if it's a what do you call like a command shell. In command shell, what you do is you run a program and that program runs inside that. Correct? In the similar way, you tell Yarn that this is my program, can you run on all the computers that have this particular file? Okay, so you tell Yarn that here is my program, can you run this program on those computers which have this particular file? Now Yarn will do that. Now you do not generally interact directly with Yarn. You interact with Yarn via the other software construct. The other software constructs such as MapReduce, such as Apache Spark. So when we write a program in Spark, meaning uh, we write a program for Spark that these are my instructions, we give it to Spark. Spark internally breaks down your program into something that can be executed on Yarn. Similarly, when we interact with MapReduce, we tell MapReduce that, hey, Here is my program which is called map. Here is my program called reduce. Can you run it? Now map reduce will take your map and reducer and will get it executed through yarn. Yarn, you can think of yarn as if it's an operating system who is executing your program on multiple machines. Okay, and making sure that only those machines which are free and available get to do the work. Okay, that is the duty of yarn. On MapReduce, we basically give our problem in terms of a programming construct called map and reduce. All right, so this is the basis of the computation. Basically, generally, in past we have been doing computation for quite some time, but why do we need to have this kind of new constructs? Reason being, all of these things are getting executed on multiple computers simultaneously. Okay, and that is why we need new kind of tools which basically help us in executing things in the network. Okay, when we go into details of each one, you will understand each and every component and why and when they are supposed to be used. Now we have HBase. What is HBase? HBase makes it possible. HBase makes it possible to store the structured data. And if you understand, Hadoop distributed file system is a file system. And in file system, you can store Excel sheet, you can store a image, you can store a movie, or you can store another database file, right? Database file as in when you store something in MySQL or when you store something in Microsoft SQL, they store data in the file system, correct? Similarly, here HBase is like your database or like your MySQL or like your Microsoft SQL, where you will be storing your data like a table. Okay, you will be saying that please change the particular cell in particular table, or please add one more column into this table. So that's how you will be interacting with HBase. Okay, so when you want to manipulate individual records, when you want to do the record wise manipulation, then you use HBase. But if you want to just save the files, delete the files, and create a new file or modify a file, those kind of operations if you want to do, then HDFS, you will be interacting with HDFS. Now we got a file system, an execution operating system, yarn, MapReduce, a programming paradigm, another programming paradigm called Spark, and we got HBase. Now, on top of these, when as an analyst, when we have to get something done, instead of saying that get the data from third record, match it with fourth record, and then keep on comparing this, instead of talking in terms of a programming language, we generally talk in terms of a query language, correct? Whenever we are analyzing data, we say that get me all the records which match this particular criteria and give me the summation of these particular columns, right? So to do that kind of logic, you use tools like Hive. So you give the query to Hive, that query gets converted internally into MapReduce and gets executed on Yarn using multiple computers. So you write your small query that will be basically churning terabytes of data using thousands of computers without you knowing it. Okay, that is the role played by Hive. So you give your query to Hive saying select star from this table where this column equals to this. Now this will be converted into MapReduce and into Yarn, and Yarn will execute those MapReduces across the cluster. So that is the role played by Hive. Now Hive is not a database. Hive is just a translator of your queries, because HBase does not provide you a query language. Therefore, Hive is required. Hive takes your query and executes that query either against HBase, which is a database, or if you have a CSV file or another tab separated file or any other format file in the HDFS, that also you can churn using Hive. Okay, so that is SQL interface to basically manipulate data in the big data environment. So most of the analytics is done using Hive. The project you will be doing in this course will be using Hive, and you can also use Pig interchangeably with Hive. Now, after some time, people have realized that Hive was not the SQL, the traditional SQL was not really designed for big data kind of problems. Therefore, people came up with Pig Latin. Pig Latin is similar to SQL but very simplified and very much highly tuned for distributed computing. And that's where the Pig Latin comes into play. Now, on top of all of this, there is a magician called Mahat. Mahat basically is a collection of great set of algorithms for which we do not have to, study data science, or we do not have to become the data scientist. Okay, Mahat contains really world class set of algorithms which you can use to manipulate to get the results. Clustering, recommendations, and categorizations, all of those complex algorithms are handled by Mahat. All right, so most of the magic is done using Mahat. So we'll go through the introduction of Mahat in this course. And on top of all of these, we have Oozie. So before we go to Oozie, let me talk about Flume and Scoop. So for Flume, Flume basically imports the data from your other machines into HDFS. So if your data is getting generated on multiple machines parallelly, you can use the Flume's data pipeline to push the data continuously into HDFS. So if you're running web servers, say 50 web servers you are running parallelly to cater to your users, then you can use Flume agent to push the data from all these machines into HDFS. So generally, Flume is used to import data, unstructured data onto HDFS. All right. While Scoop is used for importing, sorry, Flume is used for unstructured data, while Scoop is used for importing data from databases, meaning structured data. If you have your existing data in MySQL or Microsoft SQL, you can use Scoop to import all of that data into HBase, Hive, or Scoop, or HDFS. And once your work is done, once you have generated these insights, you may want to display it on the website. Then again, you will use Scoop to pull the data from HDFS, HBase, or Hive. From there, you can use Scoop and push the data into your MySQL, from where you will present on your website, present on your dashboard, or prepare your dashboard using your usual BERT kind of a usual data, the reporting tools. Okay, so that's how it works. And as you have realized by now that in a big project, you will need multiple of these components. For example, let's say you are doing a recommendation for your website. So what are the various steps involved? First, you will push all the data from your web servers into the HDFS. That will be done using Flume. Okay. Once that is done, the data has been pushed into HDFS. Once that is done, then what will you do is then you will write your queries using Hive or Pig or MapReduce, combine all these three together. You will clean up the data and form the data which is in the format of three columns, which is what Hadoop, which will be used by Mahat. Mahat, because Mahat accepts only three columns, right? In that particular algorithm. Now, but to clean it up, you will have to do the query in Hive or a MapReduce or combine together. And once Mahat generates the result, you will have to push those results back to you will have to push those results back to your usual database, maybe MySQL. Then you will use Scoop. So you use Flume to import, Hive to clean up, and then you used Mahat to generate the recommendation. Then you used Scoop to export the data back to MySQL, back to your uh, back to your MySQL or Microsoft SQL, or Oracle or any other databases. And so in this, we actually used 5 components, right? And these processes are, some are parallel, some are back to back, and so on. So to get it executed correctly, if you try to do it manually, it is going to be very error prone and very time consuming and very slow. Therefore, you need a workflow, and that's where Oozie comes into play. All right. So that was an overview of the components. Do you have any questions here? Yeah. Is Flume used only for importing? Yes. Flume is only used for building your continuous importing system, meaning as the data is being generated on your various sources, say continuously, there are thousands of webcam cams being connected to your hundreds of computers, and they are all recording the videos in parts or taking pictures. If you want to import all of that into a central HDFS storage, then Flume will be a solution. Or you are running multiple web servers, collecting the logs, error logs or normal logs. You want to continuously move these logs from the individual data in individual servers onto a central storage. So in those all cases, you will use Flume. Do we have SQL interfaces other than Hive? Also, does Hive interact with Spark? Very good question, Rajesh. So first, other than Hive, we have Piglatin, okay, which is similar to Hive that interacts with the whole ecosystem. And there are other the other components who are trying to build a similar Hive like language, but they are in a primitive stage as of now. Now next, your next question is, does Hive interact with Spark? In case of Hive, interacting with Spark is in their to-do list, but nothing has moved yet. Okay, but what Spark guys have done, they have written something called Shark. Shark is similar to Hive, meaning a SQL kind of language which basically interacts with Spark and converts basically Shark converts your SQL your SQL into something that Spark understands. Okay. Yes. So we import only we import the data using Flume, which is in many kind of formats. Okay. So now Sai Krishna's question exactly is, can we import only is the keyword, only unstructured data using Flume? So when we say only unstructured also means that even if it's a spreadsheet which is structured internally, can be copied using Flume. So Flume interacts in terms of the files instead of databases. It does. You cannot say in the Flume that select only 5 records and then push it into this database. That's not kind of thing Flume would do for you. But you can basically, in case of Flume, you can write your own connectors, okay, which can even interact with your relation. So Flume can do actually both kind of work, but when we are interacting with relational databases, using Flume is going to be a big headache, okay? Because you will have to figure out a connector which can understand SQL and can do the job, okay? But other way around, Scoop cannot be used where Flume can be used. Okay, while Flume can be used where Scoop is not used. Meaning, because structured data is similar to what is unstructured data. Sorry, structured data can be handled by Flume provided we write the connectors. All right. Any other questions for me here? No questions? All right. We have some time. So I would like to take you to a further step. Do you have any questions? All right. So Sai Krishna's question further is that can we import unstructured data using Flume? So can we import only unstructured? Yes, we can import unstructured data using Flume, as well as if you are able to write connectors. So the way Flume works is Flume works in a it has very many connectors, something called source and something called sink, and there is a pipeline, we call it a channel, that connects the source to the sink. Source and sink both are software programs, and channel is also a software program. We connect these three. Now, if you can write the source and sink, which basically reads the data from relational database or a structured database, and you can write a sink which writes to the structured database, then you will be able to handle the whole scenario, handle structured data using Flume. Okay, but it is too much of a headache, too much of a hassle when we have sophisticated tool like Scoop, which can handle a relational data far better. Then why would we go into a hassle of writing our own connectors? All right. Hope you understood what I'm trying to explain. Yeah. And Scoop, as we understand, Scoop is nothing but you tell Scoop that from this particular MySQL database, read this particular table where this particular condition is satisfied, only read on those records and push these records into Hive or HDFS or somewhere else. So that is the role of Scoop. All right. It's not only used for one way, it's both the ways. Also, you can say that read my data from Hive HBase and push this data into this particular MySQL. So you can do the both ways using Scoop. So Ravi's question is, so in HDFS, the data has structured and unstructured data. So in HDFS, so if I ask you the same thing, do we have in our file system, like in Windows, we have C colon, D colon, we are putting files in that. So what kind of data are you putting there? Are you putting structured data or unstructured data? Basically, you are putting your files there. SDF has no clue about what is there inside your file. Okay, it doesn't matter to HDFS what is inside your file. All right. All right. Now, this will be a quick overview of how to export unstructured data from where. So your question is probably, Sai Krishna's question is then how to export the data from the HDFS to some other, because Flume is only one way, correct? Yeah. So generally what happens is when you are reading the data from things like HDFS and putting it into somewhere else, then somewhere else, if it is not HDFS, then generally you only copy part of the data, because in HDFS the data is really huge. And the reason why HDFS is generally designed is it acts like a common sink. It acts like a common storage for the whole organization. All right, that's how the HDFS is built. Okay. Now, so it's generally very rare to take the files from HDFS and put it somewhere. Even if it is, even if that you want, then HDFS provides you proper commands to do that. HDFS provides you a proper set of commands to read the files from HDFS and copy it to anywhere else. Okay. So the reason why Flume is designed then is because Flume has been designed to absorb the data from thousands of computers into HDFS parallelly. And that's how it has been designed, because that's where it was needed. Okay. So while exporting the data from HDFS, you generally use the HDFS commands. Also, although by default the connectors in Flume has not been designed in a very friendly way such that you can read from HDFS and put it somewhere, reason being that people do not generally need it. Okay. But you can always customize that. Okay. Okay. So I would like to explain what exactly HDFS looks like. All right. Okay. So now my question to all of you is, if you have 100 terabyte of data, how would you store this 100 terabyte data? Into disks, correct? Correct. So generally the way we design it, good, good. So the way we store traditionally 100 terabyte of data is in this manner. You basically build a network attached storage and have 1 terabyte drives and make 100 subfolder and mount these. Meaning you bought 100 drives, you connected these 100 drives to multiple computers, you connected these computers in the network, and then you mapped these drives into folders. So when you look at the folder, you will say, okay, drive one folder is this map to the drive one, drive two folder is another. So each folder is representing one file. Okay. So now, do you see any problem with this kind of arrangement? Correct. Correct. So first answer from Sai is data loss. Too many mount points. Good. Good. Need to keep on tracking them. Good. If one is failed, the total system has failed. Good. And Kiran's point is that If drive fails, not sure about data retrieval is slow. Good. No redundancy. Correct. Awesome. So, and a side point is that difficult to find where the data is. Excellent. Excellent. So yes, those are the problems. Okay, those are the problems that are not being handled by this. So here are the summarization of the points which you have raised. Okay, first is failover and backup. So we built this kind of a file system. You see, we got these drive 1, drive 2, drive 3, drive 4. They are network connected drives, and we are able to access them, but it has got many problems. First is failover and backup. In case drive 1 fails or there is a network disconnectivity, the data is lost, or there is no way to you basically access that data. The next question was where to store which data. Okay, that would lead to a lot of problems if you try to do manual distribution of data, saying all the movies starting with A should go to this particular drive, all the movies starting with B go to this drive. That way we'll not be able to distribute the data uniformly. Is this the best value for money? Because we attached 1 terabyte drives into hard network, we might be having 200 GB drives also. Did we utilize those? No. Reason being that if we try to go for smaller drives, if we have bigger file, we'll not be able to store in the smaller drives. Correct? And therefore, this basically does not give us the great value for money. Next is, what about increasing accessibility? Question is that in case there is a big file and that is stored onto a particular machine, right? If there is a big file and that is stored into a particular machine, and and say more than 5 people want the same file. Now, if it is stored on the same machine, meaning same hard disk, and which means it's a single header. Header is a physical device, and therefore it is going to take a lot of time to read the data from this disk, right? Therefore, accessibility is pretty poor. Next is scaling out. Today you need to store 100 terabyte data. Tomorrow you might have to store 200 terabyte data. Then what would you do in those cases? And that's where HDFS comes into play. All right? That's where HDFS comes into play. And this is the architecture's quick overview. First is HDFS is built of two kinds of machines. One machine we designate as name node, okay? And other machines we designate at data nodes. So if we have 5 machines in our network, 5 computers in network, we will designate one machine as admin node, the machine which has bigger RAM, while rest of the machines we designate as data node. Name node store where is which file, the metadata, while the actual content of a file is stored inside data node. Okay, so admin node is sort of a single index where we keep on noting down that this file went to this place, this file went to this place, while data node actually stored the data. Okay, now next is that how is the data stored in data nodes? Each file which we are storing into HDFS, we are trying to each file which we are storing into HDFS, we are storing that into, uh, I mean, we are breaking that file into the blocks of 128 MB. If we have 500 MB file, we will break it into 4 parts. 3 parts will be each 128 MB. Fourth part will be a little smaller. Now, this basically helps us fit big file into smaller hard disks. Second, it leaves less unused space in each disk. And it also optimizes the data transfer. Similarly, it distributes the load to multiple machines. Okay, so basically, even if we have got a file of 10 terabytes, we will be able to handle it easily. We'll just break it into small files. It internally breaks it into small files and stores it into individual machines. All right, and each block or each piece each piece which is each of 128 MB, each piece is also copied thrice. Okay, there are 3 copies of each data. So if we are trying to store 1 terabyte data in HDFS, we will be storing 3 terabyte data. And this is called a replication factor. By default, the replication factor is 3. In case you want to change the replication factor to 2, you can change it per file, as well as you can change the default setting for your cluster. Okay, which means by default you can also change the replication factor to other than 3. You can have the 2 or you can have 4. All right, so basically, a replication factor means each block of each file will be replicated that many times. Okay? By default, that is the way. All right? So similarly, okay, so let me go back. So if we are trying to store a file, that file will be broken down into blocks of 128 MB. This also means that last block will be smaller than 128 MB. Okay, in case, say for example, because last block may not be exactly 128 MB. If it's a 10 MB file, then there will be only a single block of 10 MB size. Okay, if it's a 150 MB block, if your file is 150 MB, then there will be 2 blocks, one of 128 MB and other will be of 22 MB. Okay, now, in case a data node fails, then the lost block is copied to the other node. Okay, recovered from the other node, and the replication factor is brought back to 3. So if we have promised a replication factor of 3 and one computer goes down, so all the data blocks on that computer will get lost. But good news is that those data blocks will have some copies on other nodes and will be further replicated, so that the replication factor becomes 3. Meaning, since let's assume that take a case of a particular block. So it has 3 copies on A, B and C. A machine went down. Now only B and C are having a copy of this node, this particular block. Now this block will be copied to one more node, say D, such that there are total number of 3 copies of this particular block. Okay, so these 3 copies can vary from one file to another. For the discussion sake, we are just taking a case of 3. All right, and also the name node is never the bottleneck. Reason being, the structure is not like this. So it's not like name node will read from the data node and then give it to the user. No, it will be like this. User will come to the name node. Name node will redirect the client. Client means the software which the customer will use to write the data. Name node will tell the client that go and read by yourself the data from each data node. All right, so that's the structure, that's the architecture of HDFS that makes it possible to store all kind of huge data. Now your question is, now Ajay's question is, does all nodes have same configuration? No. Some nodes can be small, some nodes can be big. One node can have 1 gigabyte of hard disk, other can have 10 gigabyte of hard disk, and so on. So yes, it will take a huge space, Pankaj. And the reason is the space, when you basically connect this way, then space becomes really, really cheap. Okay. But given your requirement of having, having the safety and the backup, it makes sense to have three copies. But if you are uncomfortable in dedicating more three copies, you can change the replication factor to 2, so that for 1 GB file there will be only 2 GB space wasted, 2 GB space allocated. Now, question from Rakesh is, what if admin node fails? Okay, so for those kind of requirements, we there is a model called, first there is a backup name node. Okay, for name node we always have a backup name node. That's basically a cold copy of exactly what is there on the name node. So every transaction which name node is doing, it keeps on informing the backup name node that this is what it is. Similarly, all the data node also inform the backup name node. So backup name node is ready to take the place of name node, and in case name node shuts down, the traffic starts going to backup name node. All right. So that answers Rakesh's question and Rajesh's question. So next is 128 MB is the default that comes with Hadoop today. Earlier it used to be 64 MB size of each block, but now it's 128 MB. You can change this 128 MB to any other size. Okay. Okay. So yeah. Now Ashish's question is that if data is converted into a file system and stored in HDFS, then where database comes into picture, then you don't need. Why do you? So, okay, let me rephrase his question. Ashish's question is, if we are storing the database as a file, say we take a MySQL file and we are putting it onto the HDFS, and we are just being happy with that. So if you do not need to manipulate this file record wise, right? You want to add some record, you want to delete some record, then you do not need database. In case you need to alter this file record wise, you want to delete particular record, you change a particular cell, all of those kind of operations can be efficiently done in HBase kind of a solution. And HBase, please keep in mind, HBase is great if you have millions of rows and millions of columns, more than 10 million actually, more than 10 million rows and a million of columns. Only then the HBase makes sense. Okay. So Rakesh's further question is, which name node becomes backup name node? Okay. So so yeah. So here, unlike the MongoDB or unlike Zookeeper or unlike most of other system, the selection of name node or backup name node is not automatic. It is done by you as a system admin. You configure that this is my name node, this is my backup name node, and they will keep switching their places based on their availability. If name node shuts down, then backup name node takes its place. Then uh, you repair your name node and try to fix it, and then configure that name node as backup name node. And the moment the current name node shuts down, the it again will fall back to the new name node. All right. Kiran's question is, data in the RAM means it uses cache, so more memory. Does it use any algorithm for the same, same, say, more read data in cache RAM if not synced to the disk? Yeah. So when I say that admin node keeps data into the RAM, it also keeps a copy of the same data in the disk, because in case name node crashes, data can be recovered from the disk. All right, it uses that. Also, the full data, whatever data it has, it always keeps it in the RAM. Okay, it's not keeping it partially. All right, so whenever you are building a name node has to have a bigger RAM. The moment name node senses that the the memory is low, it starts creating the bigger blocks bigger blocks instead of 128 MB, so that the metadata is generated small. Okay, so Rahul's question is, so there is no option to manually or automatically switch between primary and backup? So yes, switching between primary and backup is automatic. Okay, just that we manually mark that these two nodes are our, one is admin node right now and this is my backup node. Okay, if something happens, then one label is okay, but next time when we bring it back, we will just add it that this is my current backup node, and then the moment name node fails, it will take its place. Okay, unlike in case of MongoDB or other system where data node can become the admin node, kind of a model is not here. All right, and there are solid reasons for that. Okay, so that pretty much sums up what we wanted to discuss today. Okay, all right, so a lot of questions come on to us that what is Cloud Labs. Basically what we have done is, the way it is done in organizations, that there is a central cluster installed for all the developers and analysts. They all work on that cluster and churn various kinds of data. In the similar way, we have set up a cloud lab on which we have already installed Hadoop for you, so that you can right away SSH or remotely log in into our machines, so that you can start working on Hadoop and Spark and all of these tools from the day zero. Okay, and basically when you go into any organization, that's how you will be working. Unlike the model which was there already before we started big data trainings, the model that existed was everybody was using the virtual machines, and virtual machine is not the way people should be learning, because virtual machine gives you only a single machine's point of view. In real life you have multiple machines, and that's how it should be. Okay, and therefore we have dedicated a cluster to our students, so that they can simply SSH, or using putty they can connect to our servers and start working on pig or anything from anywhere, from office, wherever they left. Say you are writing a query right now, and now you went to office, now you can resume your work there in the office. Okay, so that's where the cloud labs comes into play. If you are using desktop, home laptop or office laptop, it doesn't matter, you can connect from anywhere and start working, and that's how generally it is worked. So that is cloud labs we provide for 50 days. Okay, and those who have signed up with us, they can log in into console and see there is basically the admin console. Okay, this is our admin console, and this is the way we basically interact with services called Hue. The current installation in our cluster is based on hot, Hortonworks, not Cloudera. Okay, and okay, so this is these are the various components we have. It is showing the overall status. We have 4 out of 4 data nodes up, and name node is also up, and these are the various tools which are running continuously. And this is your file browser. Okay, this file browser shows the all the files available in the file system. Okay, this file browser is for HDFS. Now you can think of these files are stored, broken into data nodes and name nodes. Okay, so from the looks of it, you can see that this is a single file system. It might be that this file of Amar might be existing on one particular node, while the other one might be, this particular file might be existing on another node. Okay, but to the user, HDFS shows you a single view. Okay, this is HDFS. All right, and those who are in our session, they will get the details about how to log in into our this thing, Cloud Labs, and then they can start using the system from day zero. All right, and you will also see under my courses, you will see the list of courses which are in that. You will see two more courses. One is for regular expression under session 1 itself, and other is for Java course. Those are complementary course from our side, so that you, if you are interested, you can start working. Also, as you have logged in, those students who have already logged in into the session, they will see the recordings of the previous session. We provide those recordings to the students, so that those who want to start learning right away, they can start watching the recordings. Okay, and as and when our session finishes, those old recordings are replaced with the current recordings. Okay, every session is recorded and kept in the system, so that in case in future you want to review your recordings, or you want to revise a particular topic, you can come back, or in case you miss a particular portion, you can come back and attend to it. Okay, so that's about LMS. And those who have signed up, they will also see this quiz, and you can attend to this quiz. It has got some questions, so you can start the quiz, and you can learn from there. Okay, and quiz is probably the best way to learn, so you can start learning right away. And the assignment sections of LMS will contain the assignments for you. Okay. All right, so this is little overtime, 10 minutes. I mean, the break time, I had taken the break for 10 minutes. All right, great. So, yeah, any questions on this for me? So, next session is starting on 30th May. Okay, it's 11 a.m. ET or 8:30 p.m. IST, and we have on 6th June another session starting from 7 a.m. So you can sign up for any of the sessions, and you can continue rest of the sessions. So this was first session out of 11 sessions, or you can say first class out of 11 classes. Each class is going to be 3 hours long. All right, any questions for me here? All right, thank you, Pankaj. Thank you. I'm happy that you liked the session, and you found the session great. All right, so feel free to get in touch with us at reach us at No Big Data if you plan to go ahead. But nevertheless, we'll be sending you the recording and the presentation, so that you can continue learning. Okay? Okay. Thank you, Sanit. I'm happy that you also found the session great. Thank you, Seth. Okay, so Seth's question is, will this course also cover the deployment of Hadoop? So basically, the brief overview of how to deploy Hadoop will be covered. But since it's not an admin course, it's more of a big data analytics or developer course. Therefore, the installation of Hadoop is not covered. But it's not a big deal. If you are interested, we can help you out with that. Okay. Thank you, Sanit, if you found it very informative. Okay. Welcome, Sai. Okay. Thank you, Ajay. I'm happy that you found it useful and informative. Thank you, Rajesh. I'm happy that you found it very informative and okay. So feel free to spread the word around and yeah. So Pankaj's question is, are the classes be held on Saturday, Sunday? Yes, these classes are only on Saturday and Sunday because these classes are designed for people who are maybe already working, and therefore these classes are very suitable for lots of people who are already working elsewhere, and that's why. Okay. Thank you, Kiran. Yeah. Stay in touch. If you have any questions, feel free to discuss it on our forums here. Okay. There are a lot of questions people keep on asking. Okay. There are no unanswered questions right now. Yeah. So keep on asking the question on the forum, and I would be more than happy to answer to your questions. All right. So we have, if you go to our website, you will have to register there, and then you can see the forums. Okay. Okay. Thank you, Sukanya. Stay in touch. Thank you, Lohit. Thank you, Seth. Yes. So, Pankaj's question is, does the cost include certification also? Yes. So the certificate which we provide is free of cost, is based on your performance. We do not charge anything extra for that. All right, Pankaj? Okay. Thank you, Nandita. I'm happy that you found it informative. Thank you, Pramesh. All right. Okay. Thank you, Rahul. I'm happy that you found it interesting, and I'm flattered by your compliment. Kiran's question is, Python is okay as a developer or does Java? No, Python is good enough. Kiran, you don't need to go for Java compulsorily. Nothing to worry. Okay. Okay. Thank you, Dinesh. I'm happy that you found it a great introduction. All right. Okay. Thank you, Ragini. And so Pramesh's question is there any international certification like SCJP? Yeah, so there are these companies like Hottenworks and Cloudera. They do provide their certificate, but there is no single standard per se. Okay, okay. Thank you, Pankaj. I look forward for getting in touch. Okay. So Saif's question is, can Mahout be sufficient for analytics? So, okay. So for analytics, you generally use Big Hive in combination with Mahout. Okay. And sometimes you run R also on top of Hadoop. That is also possible. Okay. We'll show you how to run an R program on top of Hadoop. Okay. Kiran's question is, can think, okay. So, okay. So great. Thank you, Kiran. Looking forward to have more interactions. So Dinesh's question is, can I just take the Cloud Labs without theory? That will be difficult for me. Okay, so these basically the cluster is provided only to our students, and because we make sure that first, I mean, people use the cluster in the way we have designed it to. Second, it's already a quite a scarce resource. Okay, as and when we keep on scaling it up whenever we have more users. So we generally give it to only the students. Rajesh's question is your course online or physical classroom? So these are all online course, just like today's class. It will be rest of the course will be like this. Only the difference would be that your you will be able to see each other's question, so that I will not have to keep repeating the questions the way I'm repeating just now. So everybody will be able to see the other people's question. Okay. So now lots of people ask us a question that why do we have this only online? We don't have classroom. The first reason is that the learning is better online. This is what we have observed. All the people who have attended our online classes, they all have finished the quiz, assignments, and everything. But those people who do it offline, they don't are not able to finish our quiz and exercises. So that's the reason we realized that there's something really, really wrong in the physical classes, and that's where we stopped the physical classes. All right. Okay, so see you, and I mean, looking forward to interact more. Even if you are not taking up the course, it is not a big deal. You stay connected. You interact on our forums, all right, and stay connected. And we keep on posting new nice information on our blog, and stay connected. And all right, great. Bye bye. Have a great day. I'm muting it, and then I'll exit the session. Thank you, Seth. Good night. Bye bye.